Okay, good evening, guys. So, in our last session, we learned about ternary operators, right? And I think I've given one example also to verify how to bracketize the expression. I think I've given two examples, right? One or two. Two examples I've given. Yeah. This is one example for which I ask you people to identify the order of bracketization, and this is yet another example, right? Now what we are going to do is that we are going to identify the order of bracketization for both the cases. How the precedence and associativity will come into the picture, we want to see. So let us first start with this one. This is the code. This is the coding we are having. Okay, now so this is the expression for which we want to know what is the order of precedence and associativity. First of all, how many conditional operators are present here, and on top of that, is the statement or expression is syntactically okay or not. One asking sign, two asking sign, 3, 4. So I must have 4 colon. One asking sign, two asking sign, 3, 4, 5. 5 asking sign is there. So how many colons I must have? 3 colons I must have. Okay, 5 or 6. 1, 2, 3, 4, 5, 6. Acha, 6 asking sign is there. 6 asking sign is there, not 5 guys, 6. Then as per that, how many colons I must have? 6. 1, 2, 3, 4, 5, 6. Okay. 6 asking sign, 6 colon. So syntactically, no issue. Now we can start evaluation. How can we start evaluation? Conditional operator, associativity is right to left. Conditional operator associativity is right to left. So what is the first conditional operator? This asking sign. Who is the associated colon with this? This fellow. Now for this asking sign, this is expression 2 guys. This is expression 3. This is expression 2. This is expression 3. Question is, then who is the expression 1? So before this asking sign, I'm moving until the colon. Until I'm having the colon, whatever part is there, this is none other than my expression 1. So that means this is expression 1, expression 2, expression 3. So the very first thing that I can do is that I can bracketize that part. So this part is done. Next, what is the next asking sign? This is the next asking sign. For that, who is the expression 1? This is the expression 1. Who is the expression 2? This is the expression 2. Who is the expression 3? This is the expression 3. For this asking sign, this is my expression 2 and this is my expression 3. Then what about the expression 1, sir? What about the expression 1 for this? Just I'm moving from here, and then suddenly one asking sign is coming. So before that, so that means this is my expression 1. So that means for this conditional operator, this is expression 1, 30 is expression 2, and the entire bracketization part is expression 3. Entire bracketization part is expression 3. What I'm going to do is that I can put them in the bracket. Next, and after that, another asking sign is there. For this asking sign, who is the expression 1 and who is the expression 2 and who is the expression 3? This is definitely the expression 2. This is the expression 3. This is the expression 2. This is the expression 3. Then what about expression 1? I'm moving from here, moving from here, moving from here up to this. Before I reach the another asking sign, this part is none other than my expression 1 for this conditional operator. So this is from here, expression 1, bracketization part entirely is expression 2, and 60 is the expression 3. 60 is the expression 3. So what I can do is that I repeat one more time. For this asking sign, this is the expression 1, this is the expression 2, and this 60 is the expression 3. So from here to here, I can make a bracketization. From up to 2 to that 60, I can put it into the bracket. Okay. Anything left? Now, for this asking sign, what is going to happen, sir? I have just done it for this one. Now this asking sign. For this asking sign, this entire part is the expression 1. This entire part is the expression 1. And expression 2. This entire part is the expression 2. And this is expression 3. This is expression 2. And 70 is the expression 3. Then what about the expression 1, sir? How for the expression 1? 5 less than 8. 5 less than 8. Then I'm suddenly getting a colon. So that means from here, this is my expression 1. This is my expression 1. So what I'm going to do? This is my expression 1. This is my expression 1. 5 greater than 8 is the expression 1. For that, this is the expression 2. This is the expression 2. And then this part is the expression 3. So what I can do here, from here to here, what I can do, I can put it in a bracket. Control V. Now, what is left? Till now, up to this, we have bracketized. Next, which part is left? If you see here, still we are having one asking sign, another asking sign is left. Now, for this asking sign, who is the expression 1 and who is the expression 2 and who is the expression 3? That is what we have to decide, right? For this expression, for this asking sign, who is the expression 1, who is the expression 2, and who is the expression 3? That is what I have to define. And see here, 2 greater than 5. 2 greater than 5. Asking sign, 2 greater than 5. Acha, here I think there is a mistake is there. 2 greater than 5, 2 times came, na? 2 greater than 5, how many times it is there? 2 greater than 5. This one, na? 2 greater than 5. Asking sign, 1 colon, 1 minute. Let me verify it once. 2 greater than 5. Asking sign, 10 colon. Okay. 10 colon 20 colon 5 less than 8. Asking sign 2 colon 2 not is equal to 2 greater than 5. Yeah, this is okay. This is okay. Now we are left with how many asking sign? 1 asking sign, 2 asking sign, and we are left with 2 colon. Okay, for this asking sign, what is the expression 1? Up to this will be the expression 1. Okay, this is the expression 2 and this is the expression 3. So that means what we can do is that for this one, what we can do, we can bracketize that, this part. Yes, perfect. Next, we are left with how many asking sign? 1. For that, this is the expression 1, this is the expression 2, and this entire part is the expression 3. Now my bracketization is done. And now if you want, even you can put one more bracket. That is for your understanding purpose, but not required. If you want, you can put another first bracket open, first bracket close, but it's not required because now I'm going to evaluate this. So whether you are keeping this entire thing in the bracket or not, your choice. Let's start evaluation. 2 greater than 5. What is the answer? False. If the answer is false for the conditional operator, which is the answer? Expression 3 is the answer. So for this conditional operator, who is expression 2? This is expression 2. Who is expression 3? This is expression 3. So who is the answer? Expression 3 is the answer. So that means now my focus will be here because I have to evaluate this part to get the result. Here, 5 less than 8. Is the answer is true? Yes, the answer is true. So for this conditional operator, what is the expression 2? Because once the condition is true, that means expression 2 is the answer. So for this conditional operator, this is what is the expression 2. Up to this is the expression 2. So that means now my concentration will be to develop this part. Now here, see these guys. 2 not is equal to 2, 2 greater than 5. Who is having high precedence? Greater than is having high precedence. So which part will be executed first? This part. Is 2 greater than 5? No. Relational operator. What answer will be returned? 0. Now this part will become what? 2 not is equal to 0. This part will become what? 2 not is equal to 0. 2 not is equal to 0 is true now, guys. 2 not is equal to 0 is true. Then automatically which part will be executed, sir? This is the part that is going to be executed because expression 2 will be evaluated. So now my concentration is to evaluate this part. Now here, see guys, not 5, logical not 5. Already we have learned now. Logical not makes what? Makes a true value to false value. Makes a true value to false value. So logical not will treat here which value? 0. What value will be considered? 0. Is 0 is a true value? No, 0 is a false value. So that means 30 will not be evaluated. Which will be evaluated? Expression 3. Which part will be evaluated? Expression 3. Now my entire concentration came here. Now what I will do? I will start evaluating this one. How many operator is there? See, it's logical not. This is logical not. But this is not is equal to relational operator. This is what? Logical not. Logical not is a unary operator. Unary operator is having high precedence. So not 1 means what actually? Not 1 means what? Sir, it's a false value. That means 0. Is 0 not is equal to 1? Is the value of 0 is not equal to 1? Yes, 0 is not equal to 1. 0 and 1 are not same. Then what should be the answer? 40 should be the answer. 0 not is equal to 1. That is a true value. Then which part should be evaluated? 40 should be evaluated. Then what should be the answer? 40 should be the answer. Let's see. Execute, compile and run. Anything is there or I need to comment this entirely. Let me comment this. Execute, compile and run. The value of A is 40. As per our expectation, the value is 40. Tell me, students, do you have any doubt or you understood this conditional operator, this big drama here, how it is internally evaluated, how to consider the precedence and associativity for the conditional operator? When we are having more than one conditional operator is present, how the things will be considered? Do people have any doubt, guys? Everyone enjoyed this clarity? Everyone make response, students, so that I can understand. Chetan, Rakesh, understanding, guys? Rajshekhar. Yeah, good. Now let us go for this one. This one is a bit easier one comparatively because the expression is not that much complex like this one. So I hope you people have already, it's the same one I copied now, guys. 1 minute. Yeah, this one. This one I think is a bit easier compared to this one because we are having less number of conditional operator is there. Anyone? Can you tell me, guys, what is the answer for this one? without evaluating. Without evaluating, can anyone tell me what is the answer for this one? Yes. So one student have given the answer. Let's see whether it is correct or not. This is what is the answer of one student, right? Let's see, is it really this one or not? Then what we will do, first count how many conditional operator. 1, 2, 3. 1, 2, 3. How many colon will be there? 3. 1, 2, 3. Syntactically everything is okay. Now first this conditional operator, for him what is the expression 1? This is the expression 1. Expression 2, expression 3. Very easily we can bracketize. Very easily we can bracketize. Done. Next, this is the conditional operator. Now 8 greater than 2. You have to be very careful here, right? If you consider this as the expression 1, if you consider this as the expression 1, then this will become the part of, if you consider this as the expression 1, obviously this will become expression 2 and this will become expression 3. As a result, what will happen? This entire part will become the second operand of and. This entire part will become second operand of and. No. That is not the correct thing. The correct thing is that before the asking sign, up to this entire part should be considered as expression 1. Why so? Why so? Because then only the logical and will have this fellow only as its second operand. Then only logical and will get this one as the second operand. So that's the reason for this conditional operator, this entire part is my expression 1, this is my expression 2, and this is my expression 3. So what we can do here is that this entire part we can make under a bracket. Okay, na? Lastly, this is my expression 1, this is my expression 2, and this is my expression 3. So what we can do that, if you want you can do that, otherwise not required. Put the bracket here. Now go for evaluation. First, 2 greater than 5 not is equal to 1. Which part will work first? Greater than having high precedence. So 2 greater than 5, false, that is 0. 0 not is equal to 1, that is true. Once that is true, which part will execute? This part will execute. This part will execute. So I will concentrate on this part. Next, this is the expression 1. This will evaluate it first. In the expression 1, 5 less than 8. What is the value? 1. Will you go to the other half? Yes, I will go. 8 greater than 2. What is that value? True. Enter result is what? 1 and then 1. Enter result is what? 1. Once it is 1, which part will be taken? Expression 2. What is expression 2? Up to this is expression 2. Next, here, this is my expression 1, which is a true value. Then which part will be considered as the answer? Expression 2. Then what should be the answer? 10. So this is perfectly okay. Very good. Let us verify it once. Execute, compile and run. The value of A is 10. So whatever the fallacy, where fallacy can arise, right? Understanding the operator perfectly, where is the chance where we can make the mistake, everything with respect to this particular operator. In the last session, I discussed. Today, no fallacy, just directly I'm giving you the clarity. What is the answer for this one and how to evaluate this. Now, I think any problem statement related to this conditional operator, doesn't matter how many conditional operator they put, even you can put any number of conditional operator. I hope very easily you will get the clarity and will be able to get the answer. So this is all about conditional operator. Next and after that, we will start learning the bitwise operator concept, right? And in the bitwise operator, mostly very, very important is left shifting and right shifting of negative number. Positive number left shifting, positive number right shifting is very, very easy. But how to do the negative number left shifting and negative number right shifting? That is very, very important. And there another very important discussion is there, that is called as signed and unsigned. Signed integer, how to represent, what is the range for the signed number, and another one is the unsigned. Both this signed and unsigned story I want to bring for this shift operator under the shift operator discussion. So let us first start with left shift. Yeah. Suppose, for example, first let us start with positive numbers. Okay. Suppose, for example, here I'm writing printf 5. This is called left shift operator. Currently we are discussing about bitwise operator. How many bitwise operator are there? So many bitwise operator are there. Number one, bitwise and symbolically 1 ampersand. Next and after that, bitwise or symbolically this. Next and after that, bitwise XOR. Acha, bitwise OR is like this. Bitwise XOR is like this place. Yeah. Next and after that, left shift. Left shift is basically 2 less than. Basically, how to remember? Most of the students forget to how to write the left shift number. Very simple. How you write L, guys? Just make that L a bit angular. It will become left shift, and make it and go for it 2 times. Just the reverse of it will become right shift. There we will discuss both positive number and negative number both. And lastly, we are having bitwise complement or bitwise not, or some people call it as a complement operator. Complement, bitwise not or complement operator. Both the terminology are same. How it looks like? It is the tilde sign. Now, why they are called bitwise operator? Because they works on bit. Bit means what, guys? Bit is the short form of binary digit. Bit is the short form of binary digit. Now, let us start with left shift and right shift first of positive number. Suppose here I'm writing 5 left shift by 3 is equal to percentile d. And here I'm having 5 left shift by 3. Say, for example, we are having another one. Printf here 4 left shift by 4 and 4, it is 4. What will be the answer in this case? Very simple. Left shift means what? Left shift means what? Left shifting of a positive number. Left shifting of a positive number means, yeah, already some students started giving the answer. Yeah, left shifting of a positive number means multiplying the number. Left shifting of a positive number means multiplying. So automatically you can understand that 100% the number is going to increase. Yes, Chetan, Madhulina, your answers are correct. Left shifting of a positive numbers means multiplying, multiplication. Okay, that means the number will be increased. Left shifting of a positive number means multiplying the number by 2 to the power. 2 to the power. Now, why 2 to the power? Why 2 to the power? Because it is a bitwise operator. And how many bits you are having availability? 2 bits, 0 and 1. Other than that, you don't have any other bits. So always bitwise operator means we're talking about 2 bits, 0 and 1. So that's why it is always 2 to the power. Multiplying the number by 2 to the power number of bits. 2 to the power number of bits. Okay, 2 to the power the number of bits by which we have to make the left shifting. By which we have to make the left shifting. See here, this is the number. 5 is the number. And by 3 we have to make the left shifting. So answer is, as per this, left shifting of a positive number. So left shifting of 5 means multiplying the number. Let me multiply the number by 2 to the power. 2 to the power. Number of bits by which we have to make the left shift. We have to make the left shift here by number of bits is 3. So basically 5 into 2 to the power 3. Exponentiation is having high precedence. So it will become 5 into 8 and hence the result will become 40. With same explanation, 4 into 2 to the power 4. 4 into 2 to the power 4. So basically it becomes 4 into 16 and hence it will become 64. Right shifting is exactly the same story. Only thing is that instead of multiplication, it will become the division. And hence you can understand that, sir, positive number left shifting and positive number right shifting is not a very big issue. Very simple one. This will be dividing the number by 2 to the power the number of bits by which you have to make the right shifting. Let's take an example to understand how to go for that right shifting. Suppose you are having 5 right shift by 3. 5 right shift by 3 means what? Tell me, students. What will be the answer? 5 dividing the number by 2 to the power number of bits. What is that? 3. That means what? 5 by 8. 5 by 8 means we will take the quotient. Hence the answer will be 0. Hence the answer will be 0. So right shifting of this means it's 0. Very good. Next, sir, left shifting of a negative number and left shifting of a right shifting of a negative number. How to do that? Observe carefully. So before telling you left shifting of a negative number and left shifting of a positive number, automatically their complement operator will come into the picture. Left shifting of a negative number. How the things actually happens here. Left shifting of a negative number. What is the algorithm we are going to follow? Step 1. Represent the given number. Which number? Negative number. Negative numbers are always represented in computer memory in the form of 2's complement form. Negative numbers are always represented in our computer memory in the form of 2's complement form. So represent the given number. Here given number means definitely a negative number. How? Represent the given number by using 2's complement form. By using 2's complement form. What does it mean? Suppose, for example, a given number is there for which you have to make the left shift. Then what is the first activity you are going to do? The very first activity that we are going to do is that represent the number in 2's complement form. Suppose it is given -2 left shift by 3. Here what is the number? -2 is the number. So what is the first activity we have to do? We have to represent -2 in the form of 2's complement. Now here the question that may raise is, what about the 2's complement? What about 2's complement? Okay. 2's complement means 1's complement plus 1. 2's complement means 1's complement plus 1. That is called 2's complement. So what we are going to do here, first -2. How to represent -2? Forget about -2. First you think about how you represent 2. First you think how you represent 2. Yes, 2 is 1, 0. But the problem here is that you will not be able to get the correct answer most of the cases, if you represent it like the number by 4 by 2 digit, 4 digit, 6 digit, 8 digit, no. Just go for, as per this particular compiler is concerned, it is taking the integer size as 4 bytes. 4 bytes means how many bits? 32 bits. So represent it in the form of 32 bits. 4, 5, 6. How many bits are there here? 8. I have to represent the number in the form of 32 bits. No problem. Let me copy this. 32 bits now. 8 plus 8, 16. Of course, definitely on the left hand side. Here, here. Okay, na? Just we represent the number in the form of 32 bits. So this is the representation of 2. Okay, what I have to get? 2's complement of this number. What is 2's complement? 1's complement. What is 1's complement? Symbolically, 1's complement is denoted in this way. Symbolically, 1's complement is denoted in this way. This is denoted as 1's complement. Tilde 2. What it will do? All the zeros that are present here, it will convert it to 1. All the zeros will be converted to 1. And all the ones will be converted to 0. That is what is the role of complement operator or bitwise not. So for the discussion of this one, parallelly, this discussion is also done. Where it is? Where is that one? Yeah, 6th one. These operator discussions are automatically coming here as a part of this discussion. This is automatically coming here. Bitwise not or complement. Okay, so 2's complement is ready. But I want 2's complement of 1. So that means what I have to do here? I have to go for plus of 1. I have to go for plus of 1. If I go for plus of 1, what is the result? Observe carefully. 1, 1 is 0 with a carry in 1. So this is the 1. This is that 1. Now from here to here, all 1 will be copy pasted. All 1 will be copy pasted. This is the result that we are getting in the form of 2's complement of the given number. Here, what is the 2's complement of the given number? Given number also is 2. Given number is 2. Given number can be anything, but I have to always get 2's complement of the number. And this 2's complement number, this is basically equivalent to your minus 2. This is the number, this is the binary number. Sir, why you are converting to binary number? Array, you are dealing with bitwise operator, na? All these are bitwise operator. You need bit. What is bit? These are bits. These are nothing but bits. So this is your minus 2, guys. This is your minus 2. So that means just now I completed the step 1, sir. Next and after that, what about this step 2? What about this step 2? Currently we are dealing with negative number left shifting, where the very first step is find the numbers 2's complement. Up to that we have done. Next, what is step number 2? Now I need to perform left shifting. Left shifting, step 2. What is step 2? Left shift the number. Left shift the number by using the number of bits by which you are asked to make the left shift. So you are asked to make the left shift by 3 numbers. So that means what I have to do? Now I have to left shift the number by how many bits? 3 bits I have to make the left shift. By 3 bits I have to make the left shift. So that means this fellow will be left shifted. This fellow will be left shifted. This fellow will be left shifted. So if all the numbers are left shifted by 3, then automatically what will happen? Automatically what will happen? Automatically what will happen? there will be a vacant position created. There will be a vacant position created. Where the vacant position will be created? If you shift towards left, then where the vacant position will be created? On the right hand side. So in my right hand side, 3 vacant position will be created. All the numbers are shifted towards left. So in my right hand side, 3 vacant position will be created. So how the number is looking now? This is how the number is looking like. This and 3 vacant position. 3 vacant position. Sir, how you got the number? Very simple, guys. If the number is shifted by 3 towards left, automatically he will be gone. This fellow will also gone. This fellow will also gone. So where this fellow will come? To the position of this fellow. Where this fellow will come? To the position of this fellow. So like this 0 will come here. Na? Every number is shifted to the left by 3 bits. Shifted to the left by 3 bits. Shifted to the left by 3 bits. This is what the number is looking like. Now for negative number left shifting. For the negative number left shifting, always remember step number 3. What is that? Fill up the vacant position. Fill up the vacant position on the right hand side by 0 value. Fill up the vacant position on the right hand side by 0 value. Then how it will look like? Here 0 will come, 0 will come, 0 will come. Next, what we are going to do? Before doing anything, make sure you arrange it in 8-bit form. 3, 4, 5, 6, 7, 8. Next. From here. 1, 2, 3, 4, 5, 6, 7, 8. From here. 1, 2, 3, 4, 5, 6, 7, 8. From here. 1, 2, 3, 4, 5, 6, 7, 8. This is the current status of the number after left shifting by 3 bits. This is the current status of the number after left shifting by 3 bits. After left shifting. After left shifting. This is the status. Okay, na? Next, step 4 and final step. What is that? In most significant bit, if the most significant bit, who is the most significant bit here? This is called most significant bit. This is called least significant bit. This most significant bit is called signed number, signed digit. This is called signed digit. It will decide the sign of the number. Signed bit. It is called signed bit. Most significant bit or most significant digit is also called a signed bit. If most significant bit is 0, then very easy. Then just convert the number. Convert the number means whatever number you got. If the most significant is 0, in that case, then convert the number from binary to decimal to get the required answer. But very unfortunately, here the most significant bit is not 0. Then otherwise, that means if the most significant bit is not 0, that is the meaning of otherwise. Leaving the most significant bit means what? We are not going to consider the most significant bit. Why? Because Most significant bit is for the signed representation. Most significant bit is the signed representation. So we're not going to consider the most significant bit. Otherwise, leaving the most significant bit, take the remaining numbers. Take the remaining, not number, take the remaining bits. That means except the most significant bit. Take the remaining bits. Take the remaining bits. 2's complement. Take the remaining bits 2's complement to get the required value. Now you see here, this is the most significant bit, which is 1. What they are asking? Leave that bit. Leaving the most significant bit, leave that. Take the remaining bits. What is the remaining bits? This is the remaining bits. Take this. So, as the most significant bit is 1, we are leaving that and taking the remaining bits. Taking the remaining bits. Then what we are getting? From here to here. From here to here. Now what they are asking after taking the remaining bits? Identify its 2's complement. Okay. So to get its 2's complement, first what I have to get? 1's complement plus 1. That is nothing but 2's complement. Now 1's complement of the number. 1's complement of the number. Is 1's complement of the number is, what is 1's complement is? 1 will be converted to 0. 0 0 0 0 0 0 0 0 0 0 0 0 0 0, then 0 0 0 0 1 1 1 1. This is the 1's complement now, but actually one need to get what? 2's complement. That means plus of 1. Now what you are going to get after addition of this series? 1 1 0 with a 1 in hand. Again 1 1 0 with a 1 in hand. 1 1 0 with a 1 in hand. 1 1 0 with a 1 in hand. Now we are putting this one here. Putting this one here. Now from here to here, from here to here, from here to here, all are nothing other than 0. One 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 one. Yeah, perfectly right. Then what is this value, guys? 1 2 4 8 16. 16 is the value. 16 is the value. But the algorithm is not completed yet here. One more line is there. What is that line? Finally, add minus sign. Finally, add minus sign to find the required answer. So this is in the otherwise part. Finally, add minus sign to add the required result. So what is the required? What is the value you got here? 16. And what about the final result? Final answer? Final answer. They ask you what? Add that minus sign. So minus 16. Let us verify it once. Execute, compile and run. -2 left shift by 3 is minus 60. Easy na? This is negative number left shifting. exactly same, almost same, just with a little bit difference. What is that? Let me copy this. I will make these small changes wherever it is required. This is negative numbers, right shifting. So right shifting of a negative number. Represent the given number as 2's complement form. Same. Right shift the number by using number of bits by which you are asked to make the left shift. Here it will be right shift. Fill up the vacant position on the, this time not right hand, left hand. If you make right shift, vacant position will be created on the left hand side. If you are making a left shift, vacant position will be created on the right hand side. Fill up the vacant position on the left side by not 0 value, by 1 value. The remaining stories are same. If the most significant bit is 0, then convert it, otherwise same. Let us go for one example very quickly to understand the right shift. Say -1 right shift by 4. This is the example we need to know. Mostly, sometimes you need to do it very fast, rough work. For that purpose, you have to remember -1 equivalent binary number is, guys, all 1. -1 equivalence binary number is all 1. Just for shortcut, I'm telling you. How, sir? 1. 1 means 5, 6, 7, 8. 8, 16, 24, 32. This is 1. What about 1's complement? All 1. Zero. 2's complement of 1 I need. What I need to do? Plus 1. Now you see, plus 1. What is this? After taking the addition, all 1, na? So that means what? The 2's complement is nothing but negative number representation. This is nothing but what? This is nothing but your -1. This is nothing but your -1. So -1 means all are 1, sir. Okay. Now what they said? I have to make it right shift, right? So if you make a right shift by how many bits? 4 bits. So that means on the right, 4 vacant position will be created. Sorry, on the left, 4 vacant position will be created. Everyone will be shifted to the right. What will happen? On my left, 4 vacant position will be created. Let me create 4 vacant position. 4 vacant position will be created on the right hand side. This fellow will be out of the context. This will be out of the context. He will be out of the context. He will be out of the context. So that means we will have this 8, this 4 plus 4, 8, this 8, and then 4 vacant, and then this 4. Remaining 8, and lastly we are having this 8. Now here the most important point is, while filling it up, you cannot fill it up with 0 value. With what value you have to fill it up? 1. So that means once you fill it up, after filling it up, how the numbers will be looking like? Same. It will be looking like this, where all are 1. Next and after that, what is the thing? Most significant bit verification. What is that? 1. What does it mean? Leave that 1. Leave that 1. Take the remaining bits. Take the remaining bits. These are remaining bits, na? Take them. Take them. Okay. Remaining bits, take them. Then what to do? Take its 2's complement. First 1's complement. First 1's complement. plus 1 plus 1. Then what we are going to get? Plus 1. Okay, now so this is the number, but is this your correct answer? No, sir. Finally you have to add that minus sign. Na? Answer, what is the answer? 1? No. What is the answer? Minus 1. Minus 1. Let us verify it once. Printf minus 1 right shift by 4 is equal to percentile d. What is our answer? Minus 1. Minus 16 and minus 1. Okay, now guys. Left shifting of a positive number, left shifting of a negative number. I hope everyone got it. So this is all about the bitwise operators, sir. For what is called Chetan, for negative number, even with multiplication, you will get the result. If you feel that I will not go for this approach by multiplication, you can do that. But for right shift, it will not come in. Right shift, if you start dividing by 2 to the power 4, it will not come. But for left shifting, if you want to take that approach, you can take that. It will also work. For all numbers, it will work. Okay, na? But you cannot apply it for right, what is called right shifting of negative numbers. Then you have to take this approach. That's why I discuss both the algorithm for left shifting as well as for right shifting. Chetan, okay? Yeah. Bitwise AND, it is following that same logical truth table of logical AND. Same truth table of logical AND, whatever we have learned, it will follow that same truth table, right? Only thing is that it will be working on bits. Bitwise AND will work on bits, logical AND will work on that particular number. What is the logic for that? What is the logic for that? But other than that, truth tables are same. Here, what is that? Bitwise OR. Here also, the same truth table for logical or whatever we used, that is only is going to be used. Bitwise XOR, see, if both are same, result will be 1. 0, 0, 1, 1. Different gives us 1. Different gives us 1. 0, 1, 1, 1, 0, 1. Alternate gives us 1. Right? Let us go for verification of one example here. Suppose printf 2 XOR 3 is equal to percentile d. 2 XOR 3. What will be the answer? This is for XOR operation. What will happen here? Bitwise XOR. Example 2 XOR 3. Okay, very quickly. 2. Always go for 32-bit representation. Even you know that, sir, 2 means 1, 0. don't go for that 2-bit representation. That's a bad habit. And in some cases, you can go for mistake also. If you have this habit of representing with two digits, 2 bits, 3 digits, 3 bits like that. Always go for 32-bit representation. Next, XOR operation. So alternate gives us 1. So 1, 0, 1. Remaining all are 0 na? Remaining all are 0. Alternate gives us 1. So what is the expected answer? 1 is the expected answer. Let's see. Execute, compile and run. Yes, 1 is the expected answer. So once we have done this, why not the remaining 2? Simple. Printf, same. 1 is with bitwise AND, and another is with bitwise OR. Only one bar sign. /n. First one is what? Bitwise AND. What will happen? And 1 1 1 0 1 0. Then what is the answer? Next, bitwise OR. 1 0 1 1 1 1 1 1 1. What is the answer? 3. Let's see. First one is 2, next one is 3. 2. Achha, here one /n is needed. Execute, compile and run. 2 3 1 minus 16 minus 1. Let me take that one also. Complement. Complement of 2. Complement of 2. Observe carefully. Don't think just by complementing you will get the result. No. Most significant bit will come into the picture. Here. Suppose you are asked to find complement of 2. First 2. What is 2? What is 2? Sir, 2 means this. 2 means this. What about complement of 2? What about complement of 2? Sir, all are 1. 0 will be 1. 1. 1. 1. 0. 1. Now, do you think this is the answer? We will convert it to binary to decimal and that is the answer? No. Again, as the most significant bit is 1, remaining story is same. Where I wrote to that? From here. As the most significant bit is 1, we are leaving that and taking the remaining bits. Remaining bits means up to this. Once complement of the number, this is all 0, lastly 1 0. 1 0 plus 1. What is that? 1 1. What is that? 3. But is 3 is the answer? No. Final answer is -3. Final answer is -3. So 2's complement will be what? 2's complement will be what? -3. Let's see. 1, 2, 3, fourth one. Execute, compile and run. 2's complement is -3. So as we have taken everything, why not positive number, left shifting and right shifting? What is that? Firstly, what we have done? 2 left shift by 3, na? 2 left shift by 3 is equal to percentile D, 2 left shift by 3. And then printf, another one, /n, 2 right shift by 3 is equal to percentile D, 2 right shift by 3. Positive numbers, negative numbers. This was bitwise and this is bitwise and this is bitwise or lastly bitwise XOR, bitwise complement, left shifting and right shifting of positive number, left shifting and right shifting of positive number, same left shifting and right shifting of negative number. That's it. That is the discussion with respect to bitwise operator, guys. Everything is done. Now it's not the end of the discussion because tomorrow we will have session, guys. Normally Saturday is holiday, but tomorrow we will have session. Okay. Tomorrow when we'll meet, we will go for practicing of this left shift operator, right shift operator, positive number, negative number, and everything. So next class you have to be ready with your pen and paper, right? And I will give you multiple examples which we have to solve. Thank you, guys. Yeah.